Hello, my name is Dawei Liu, and I'll be presenting automatic discrimination of laughter using distributed SEMG, which I selected for a journal club in BMED 3110 A01. For brief background about the article I selected, laughter is a universal and recognizable nonverbal human social communication. It is a nonverbal social communication that is generally involuntary and involves many muscle groups. It's largely processed at a sub or unconscious level, and a better understanding of it could drastically improve human-machine interfaces, other technological applications, as well as improving the health benefits that exerts through its physiologic effects, such as an increase in heart and respiratory rate, as well as oxygen consumption. For the literature evaluation of my article, the authors found a large body of work on laughter detection and classification. However, the standard non-invasive detection relies on audio and video data, and there are situations in which those systems could not be used or considered reliable, such as long-term laughter monitoring, multiple interactions, or a noisy environment. The authors aim to provide a proof of concept of a new ecological EMG-based sensor system for measuring, recording, and classifying real-time laughter during prolonged social natural interactions. This system could be used as an alternative for a number of other laughter detection systems and classification. These situations in which other less invasive systems cannot be used would provide an opportunity for this system to work. It would also clarify the muscle motion axis and also provide a body action code system. The subjects of the study were 10 adults and volunteers of many nationalities. There were 4 males and 6 females, and there was no inclusion or exclusion criteria specified in the article. The average age of these participants was 34.3 years old, and they ranged from 18 to 63. It was performed at the University College of London with ethical committee approval and a right to privacy, written consent, and other ethical obligations and IRB approval obtained. There was no explicit sampling bias, although this low sample size may have been done out of convenience. The materials that the authors employed included their EMG prototype, which was a Waseda Bioinstrumentation System EMG, or WEMG. It consisted of 3 electrodes, 2 which were coupled for recording and 1 for reference. The considerations that the authors made when selecting this system were the signal noise rejection, and which is governed by surface area of the electrodes, the overall size of those electrodes, and where they're placed. The sensor specs are included here. The authors used the following methods to assess the participants during laughter. They focused on areas or muscle groups that were simultaneously activated, such as the respiratory muscles, the larynx, the facial muscles, arms, as well as posture, so the back. The reference to prior literature was used to determine where to actually place the electrodes. Previous articles used abdominal muscles as well as the xiphoid process, which is the tail of the sternum. However, they ultimately selected the neck due to 2 factors, comfort and convenience. They used 4 WB-EMGs to acquire their data. These included 2 EMGs as well, and 2 other control EMGs that were placed around the throat area and the abdominal muscles. Their conditions, or the elicitation techniques that they used, were watching comedic videos or having casual interactions with their friends. They sat upright in a chair during these, and the calibration to sort of determine the baseline was recorded for a number of seconds before the experiment began. As for how the data was actually analyzed, they broke down the 5 hours of recorded data into 7 categories. These included talking, reading, laughing, fake laughter, yawning, coughing, throat clearing, and of course, none of the above. A sliding window filter was applied to each labeled EMG channel data, and these were 100 milliseconds in step size and 500 milliseconds in length. The features were then extracted to be used for the discrimination techniques between their different vocal expressions. A potential limitation arose when they performed their statistical analyses. It was difficult to determine whether these statistical results were significant or satisfactory, as they only used their neck EMG data for this assessment. Rather than validating it against other classifying systems such as video, they simply looked at their own correct rates. They used PCA, or principal component analysis, and number of subsets, including linear discriminant, multi-class classification, and support vector machine, or SVM. The average correct rate for binary, so laughter or not laughter, was found to be 64% and 62% for the LD and the SVM, respectively. Further analysis encompassed the confusion matrices that they displayed their data in. They compared whether they actually detected laughter with true positives in the upper left, true negatives in the lower right, false positives in the lower left, and false negatives in the upper right. The results in discussion include that they found their time domain measures and their frequency domain measures that best facilitated improved accuracy. They found that the time domain measures were RMS and peak to peak, whereas their frequency domain measures were mean power and bandwidth. Their future directions are improving their feature extraction and the model that they selected. They found that they also exhibited somewhat inferior accuracy compared to previous works of literature that also sought to detect laughter, but they again aim to improve that in the future. All in all, in significance, they found that laughter was detectable via their SCMG-based sensors. It was less invasive than other systems, even though they are both placed on the surface. And they found that they could have shown accuracy comparisons to other systems, which I found to be a potential area to sort of establish their proof of concept. The authors were thorough, though, in their detailed procedure, and could contribute in the future to laughter studies, and this would ultimately contribute to the body of knowledge as well. Here is my reference. Thank you for your time.